Assalamu alaikum wa rahmatullahi wa barakatuh. I'm recording this again because I've realized after recording the video that the battery on my microphone has run out. It's a wireless microphone, so when the battery runs out, I have to just basically, I don't know that it runs out. It doesn't tell me. So it stopped recording the voice. That's all that happened. So I'm recording this again. Okay, let's go through it quickly. Basically, when we calculate the impulse, with the impulse, we only have 2 or 3 formulas that we're worried about. Impulse equals final momentum minus initial momentum. Remember, this is not an explanation video. If you don't understand something here, please go back and watch the original video lesson. And of course, so that means that it's going to equal mass times final velocity minus mass times initial velocity, which can also be written like this, Vf minus Vi. Okay, anyway, question 1 says force and time data. What are we trying to work out? Rank the impulses in order of increasing magnitude. So what I'm going to do is I'm going to draw another row here with columns. Okay, and hopefully that will all be very clear. So change in momentum also equals, there's another formula that we know, which is change in momentum equals force times change in time. So that's another important formula that we're going to be using as well. In this case, that's what we're using. 1 times 1 equals 1. 2 times 0.3 equals 0.6. 5 times 0.1 equals 0.5. And 10 times 0.07 equals 0.7. So obviously the answer to that one is going to be C, B, D, and finally A. Let's go to question 2. Question 2 says 0.14 kilogram baseball is dropped from rest. It has a momentum of 0.78 kilograms meters per second just before it lands on the ground. For what amount of time was the ball in the air? Okay, so the ball, here it is. It's a baseball and it's dropping down. It has a weight force. It has a weight force, and weight equals m times g. So the weight force is going to be equal to 0.14 multiplied by 9.81 meters per second squared. So the weight force is going to be approximately 1.38. So 0.14 multiplied by 9.91, 1.37. 1.37 newtons. So now we have the weight force, which is the force, and we also have the momentum, or the change in momentum, because it says it's dropped from rest. So the initial momentum is 0. The final momentum is the change in momentum. It's the same, 0.78. And so the final answer is going to be change in momentum equals force times change in t. So 0.78 equals 1.37 multiplied by time, whatever the time is. So 0.78 divided by 1.37, and that equals, so t equals 0.56 seconds. Hopefully that wasn't too tricky. Okay, let's clear the page and go to question 3 and question 4. Question 3. During a ballistic test, we have a bullet that's going to be fired across into a gel, and the bullet has a mass of 5.5 grams. It's pretty small, and it's traveling at a speed of 3 to 5 meters per second, which is also quite slow, by the way, for a bullet. And we are trying to work out what is the time needed. We've also got a force. They've given us a lot. 550 newtons. What are we trying to work out? The time it took to stop the bullet once it goes into the gel. Khalas. Okay, it's easy. First I have to work out the change in momentum, the impulse, which is going to equal it's going to equal mass minus velocity, or change in velocity, which change in velocity in this case is 325, because we don't have, the last velocity is 0. But the mass has to be changed from grams to kilograms. So 5.5 divided by 1,000. So that's the first thing, is the mass is going to be 5.5 grams over 1,000, because there are 1,000 grams in a kilo, multiplied by 325, and that will give me the momentum. So the momentum is going to be equal to 1.78. 75 kg dot meters per second. That is the momentum. And then I have the momentum, I have the force. What do I do now? Come on, remember the formula. The formula is change in momentum equals force times time. I have the momentum, which is 1.7875, and I have the force, which is 550 multiplied by t. I can find t, so it's 1.78 divided by 550. The time is equal to, therefore time is equal to 3.25 times 10 to the power of negative 3 if you like scientific notation, or if you don't like scientific notation, 0.003 seconds. Okay, thereabouts. That's the correct answer if you want to check that. Okay, I'm going to clear that now because we really have to keep moving. You can always pause the video, go back. Okay, let's move on. Erase everything. Question 4 says, question 4, when spiking a volleyball, a player changes the velocity of the ball from 4.2 to -2. Okay, so I'm just going to go back, a very, very quick, brief explanation. Change in momentum equals P final minus P initial. And remember that equals M times V final. Oops, no, I don't want that. Minus M times V initial, which equals M, because mass is the same, Vf minus Vi, if you know your mathematics. And so we know that that is the formula for change in momentum, just like, or impulse, just like force times change in time. They are both the same. Okay, so what do we have? We have change in momentum. Okay, and we have the velocity. So we have negative 9.3 equivalent to mass multiplied by the final velocity, which is negative 24 minus 4.2. Okay, so therefore mass equals negative 9.3 divided by negative 24 minus 4.2, and that gives you a mass of 0.33 kg, which is equivalently right for a volleyball. Volleyballs are quite light. If you look at football, for example, a football is between 400 and 500 grams. A volleyball is usually lighter than that because you hit it with your hand. Okay, and there you go. That's all. I'll see you in the next one.